Okay, students, let's go over the answer key to the third test here. So name the most specific quadrilateral. Notice they just give you the givens right here. We have AB is parallel to DC and AD is congruent to BC. So I put those markings on there. When we have at least one set of parallel lines, we know it's a trapezoid, and since these two segments are congruent, we know it's an isosceles trapezoid. If they were not congruent, it'd just be an isosceles. You'd just be in a trapezoid. All right. Number two, name all the possible names for this quadrilateral. When we see four congruent sides without showing four congruent angles, automatically rhombus. So how do I know it's kite, parallelogram, trapezoid, and quadrilateral? I look at my quadrilateral hierarchy that I have memorized. So I look at rhombus here. Rhombus is connected to a parallelogram here. It's also connected to a trapezoid, which then is connected to a quadrilateral, and straight up here it's connected to a kite that then goes to the quadrilateral. So you have to name everything above it. Okay. It would fit the definition because we know all parallelograms have opposite sides that are congruent. Okay, a kite just has to have two pairs of consecutive sides congruent. Well, in this case, it'd be both pairs the same, but that still fits that definition. A trapezoid just has to have one set of parallel lines, which, don't forget, a rhombus is a parallelogram, so it's got two sets of parallel lines or segments, so it fits all these definitions. Okay, so let's go back to number three. Classify the quadrilateral as specific as possible. Well, we see we have four congruent sides, and in this time it's four right angles, so that makes it a square. And then solve for x and y. Well, since they're all congruent, I can choose any of the sides I want to set equal to each other. So obviously I'm going to set the ones that have x's together. Actually, so I did it a long way here. I did systems here. I did not have to do that. I could have been smarter and set those two equal to each other and set those two equal to each other because all congruent. That would have been the smartest way. Okay, and then I would set those two. For the y's, I'd end up with 3y equals 3, so y equals 1. And for the x's, I'd get 2x equals 4 and x equals 2. Oh, I did do that right there. Okay, I did do that. I was thinking I did it with systems. No, I was smart and set those equal to each other. Okay, number 4. Given rectangle WXYZ and that the measure of angle YXZ is 53, so I put that right in there. And the length of XZ, that's the entire diagonal, is 16. Remember, it's a rectangle, so what do you know about the diagonals of a rectangle? They are congruent. So if XZ is 16, so is WY. We also know it's a parallelogram, so opposite sides are parallel. We have parallel lines cut by transversal. Well, we know all four are right angles. So, excuse me, so if that's 53, the other has to be 37. Right next to it, they're complementary. Okay, and then don't forget we have parallel lines cut by transversal as well. Okay, so that puts this at 37, this at 53. Okay, as well, we can go along with that here. All right, let's fill that in. Measure angle WXZ. Well, we know that's complementary, 90, so that makes that 37. The measure of angle WPX, WPX right here. Okay. So what do we have here? We have this is 53 here, so that makes this 53 over here for alternate interior angles. Well, then I can look at this triangle right there, which then don't forget, we know it's 90. Okay, there's our 53 and 37 for that one. So we have that. Let's get rid of that. Okay. This is 37 here. Oh, okay, we know that the diagonals bisect each other. So if that's 37 down here, this has to be 37 here because it's an isosceles triangle. So now we have a 37 and a 37 is 74. And then don't forget we have this triangle in the middle here. So then this angle that we're looking for, WPX, is 180 minus 74, which is 106. All right, let's go to the next piece, TY. Remember the diagonals bisect each other, and since the diagonals also are congruent, it has to be 16 divided by 2, which is 8. Okay, number 5. Find the interior, exterior, and sum of all the interior angles of a regular pentagon. So you got to know pentagon's 5. The easiest way would be deal with the exterior angle, which is, remember, 360 divided by 5, which then gives you 72. So I have this, 72 right there. I know the exterior angle and the interior angle form a linear pair, which means they add to 180. So 180 minus that 72 is 108 right there. Okay, well then each interior angle is 108, and there's 5 angles, so I multiply that by 5, and I get 540. Okay, so that's how I would do that one. Remember, we already have this formula of n minus 2 times 180. I could have done that as well from here, okay, and applied it up there as well, but I showed you the quicker way. But there's both those ways, so you can do that, either method. All right, 6. The sum of the interior angles of a convex polygon is 900. We know the sum of the interior angles of a polygon is the expression n minus 2 times 180. So we set that equal to 900. Divide each side by 180, and I get 5. So n minus 2 equals 5. Add the 2 across, n is 7. Okay, so you got to have that formula memorized. Find the number of sides of a regular polygon if each interior angle is 175. Well, if the interior angle is 175, then the exterior angle is 5, right? Because remember, they're supplementary. They form a linear pair, just like we did number 5. And then don't forget, 360 divided by the number of sides equals that exterior angle, so it equals 5. So I cross multiply, I get 5n equals 360 divided by 5 on both sides, and you get n equals 72. All right, that was 6. Go over here to 7 now. Find the values of each variable for the following parallelogram. We know if it's a parallelogram, we know opposite angles are congruent, and you know that. Okay, that was on your post-mod or mod 1 post test that you just took recently here. And so I set those equal each other. Okay, and I get y equals 50. Notice, so there's y equals 50 right there. Well, what do I know? So 50 right here, if I plug that back in, 50 plus 10 is 60. That's why I have 60 right there. What do I know about these two angles right here? Parallel lines cut by a transversal, so same side interior angles are supplementary. So now I have 180 minus this 60 right here has to equal this angle. So that angle equals 120 degrees. Okay, and so 120 equals 4x, divide each side by 4, and you get x equals 30. Number 8, find the values of each numbered angle of the following parallelogram. Well, obviously we have vertical angles here, so that's easy right there. And if that's 50, we have 2 of the 3, so we have triangle sum theorem. 75 plus 50 is 125. Subtract that from 180, that gives me angle 3 of 55 degrees. Don't forget it's a parallelogram, so you know opposite angles, alternate interior angles are congruent. So if 3 is 55, 1 has to be 55. I told you over and over, parallel lines cut by a transversal, the very first one you should be thinking about is alternate interior angles. And if that you don't have that, then you look for the others. But all AIA, very first one. So angle 3 is going to angle 1, so they're both 55. Okay, angle 2, nice and easy. We have a linear pair right there. 75 plus what? Plus angle 2 equals 180. So 180 minus 75 is 105. Number 9, find x and y so that each quadrilateral is a parallelogram. Parallelogram, what do we know? We know that the diagonals bisect each other. So that equals that. This equals this. Okay, so we set them equal each other. All right. So let me erase that. So we see we have 3x equals 4x minus 3. So x equals 3. Y plus 3 equals 2y minus 11. Y equals 14. So we plug those in there. And it says then name the sufficient condition. Okay. So if both pairs of diagonals of a quadrilateral bisect each other, okay, then it is a parallelogram. Remember, it's an if-then statement. A lot of you blew that on your post-mod 1 test. You didn't write it as a condition. Only about 5 of you got it right in the class. Okay, you're writing that out. There's your conditional. Remember, we wrote those down at the bottom of the quadrilateral hierarchy. Number 10, determine where the following is a parallelogram. It is not. Or this is close to number 5, but on the sufficient conditions. But number 5 says if one pair of sides is parallel and congruent. So it would have been like that, and then it would have been a parallelogram. But the hash marks are on the opposite sides over here, not on the same as the parallel. So that does not work. So the answer is no in this case. So I showed you what it would have to look like to be a yes. Number 11, if quadrilateral ABCD is a rectangle, so we know the diagonals bisect each other and the diagonals are congruent. Okay, so that means all 4 pieces are the same. AC, the whole diagonal equals that, and BD, that whole diagonal equals that, so we know the diagonals are congruent. So all you do is set them equal to each other. Okay, so subtract the 2x across, you get x, add the 6 across, and you get 10 for x. Okay, but it says find DB. So now I have to find DB. Okay, that's this right here. So notice I have an error here. I just found x. That's what x equals. I didn't go back and read the directions like I keep telling you to do. So you better learn from this. Okay, I now need to plug that x into the 10. 2 times 10 is 20 plus 4 is 24. So BD, the length for BD is 24. There's your answer. Okay, just shows I'm human. The difference, I caught my own mistake going through this. All right, number 12. If angle A is 36 degrees, okay, remember this is called a vertex angle right here. A and C are the vertex angles, and the diagonal on a kite bisect those vertex angles. So that means each side of it is 18. That's what you see right here. That's an 18 right there. And the other side would be 18. And angle C is 74. That's the other vertex angle, so it bisects that, so it makes that 37. Find the measure of angle D. Well, angle B and D are congruent. Okay, I could have put the 18 down here and the 37 down here, and then I have that triangle, so I can solve for D. 18 plus 37 is 55. Subtract that from 180, because all triangles add up to 180, and you get 125 degrees. 13. Okay, remember we have a trapezoid, and it says HJ is 18. LK is supposed to be, so cross that on yours. LK is supposed to be 40, and TS equals x minus 9. Now, what I should have had on here is I should have told you that T and S were midpoints. Okay, so that equals that, and that equals that. Okay, so now we know T segment TS is a mid segment. Okay, remember the mid segment is half of the sum of the 2 bases. So 18 plus 40. Okay. TS is x minus 9. Okay. So I could just do 18 plus 40 is 58 divided by 2 is 29. Okay. So then I know that 29 has to equal the mid segment of x minus 9. Add the 9 across, you get x equals 38. So there's my final answer. Okay. What I showed up here is I said, okay, if I double the mid segment, that's the 2 times the mid segment of x minus 9, that equals the sum of the 2 bases. And then I divide each side by 2. Okay, that's what I was showing up there. So a couple ways of doing that right there. All right, backside here. If angle K equals 3x minus 7, and angle M equals that, find the measure of angle L. Well, we know K equals M. Opposite angles are congruent in a parallelogram. 14 is a parallelogram. Okay, so I set those equal each other, solve for x, I get x equals 17.5. Okay, now it wants me to solve for angle L. Well, we know angle L and K are supplementary, or angle L and M are supplementary. because you have parallel lines cut by a transversal, so you have same side interior angles are supplementary. Or you can just remember that one of the properties of a parallelogram is consecutive angles are supplementary. Same thing. All right, so we plug the x back in. So I have 28 plus 17.5 is 45.5 right there. I subtract that from 180 and I get 134.5. 15, state if the three numbers below form a triangle. Remember, if the sum of the two smallest is greater, 8 plus 8 is greater than 12. Yes, it is. Your justification is that work right there. 16, find the range. Remember, all I do is subtract the 2. 11 minus 6 is 5. And add the 2. 11 plus 6 is 17 to get my 2. Okay. Remember, you're always doing, when you're subtracting, you do the bigger minus the smaller, so you get a positive answer. Or the side lengths from least to greatest, given these angle measures. So I put the angle measures in here. Since 42 is the smallest angle measure, I know CB, or BC is the smallest segment. You must go by the degrees, not what it looks like. 63 is the next smallest, so AC is second, and then 75 is the largest, so AB is the largest. Okay. 18, or the angle measures based off their side lengths. Let's go in the reverse direction. AB is, I just put these numbers in here since 4 is the smallest, and angle C is the smallest. What do I say? From greatest to least. Okay, so greatest is 14. So make sure you pay attention, greatest to least, this one, or this one, least to greatest. So 14 is the largest side, so it's B. The angle opposite is the largest angle. 13 is the next largest, so it makes it A second, and 4 is the smallest, so it makes C third. 19, classify the triangle. So first off, it has to be able to fit a triangle, which it does because 7 plus 9 is greater than 12. So remember, I do C squared. C is always the longest side. You just got done doing this. So 12 squared on the left, blank, 9 squared plus 7 squared. 144, how does that compare to 130? 144 is greater, so therefore it is obtuse. C squared is greater than that. Okay, number 20. We have this drawing down here at the bottom. D and E are midpoints, it tells you. So that means that equals that equals that. They're midpoints. So we have the mid-segment theorem to use right there. Okay, and it says find the following. If angle C equals 64, remember these are parallel as well. That mid-segment is half the base, and it's parallel to the base. So we have parallel lines cut by transversal. Corresponding angles are congruent. So that's why that's 64 there. Okay, angle B is 37. Well, once I put this 37 here, now I have the triangle sum theorem, so I can solve for x right there. Find the angle BDE. We know the triangle adds up to 180 degrees. So 37 and 64 is 101. Subtract that from 180 and you get 79. If DE, the mid-segment itself, is 21, so if that's 21, then we know this has to be 42. Let's double it, and that's what it asks for. It says if DE is that algebraic expression, and that solve for x. So remember, DE is half it. So if I double that, and they would set equal to AC, and that's the work I have at the bottom down here. Okay. C right there, I have the work. Okay, solve it and you get x equals 11. All right, last one, 21. Given the centroid of a triangle, if AG, so here's our centroid down here. Okay, if AG is 11, remember that ratio is 2 to 1. So that means it's double this one, so that makes this 5.5. Okay, what's GF? Well, half it, 5.5. What's AF? The entire length. 11 plus 5.5 is 16.5. Now we have for B, obviously there's ABC, there's 4 points there, so each one's a point. If AD, remember these are medians, so that means this equals this. If AD equals x plus 14, and DC is 3x minus 6, we just set them equal to each other. Okay, and solve it. So I have that down below, right there, and get x equals 10. Okay, that's, oh, okay, but it didn't want just x, it wants to solve for AC. So after I get 10, then I go ahead and plug it into one of the two and then double it. So 10 plus 14 is 24, double that is 48 for the whole length of the side there. If the length from C to G is x plus 6. C to G is x plus 6. Remember, that is going to be 2 times this other one. CE is 3x minus 8. So that means I have to double this CE one to equal x plus 6. So I look down here at C. Where do I have C here? C is up over here. Here's C. Okay. I could. So what I did is I did 2/3 of the full length. Oh, CE. Sorry, it's not CG. CE, the full length. Correct. Okay, so CE is the full length. CG is 2/3 of the full length. So that's why you see 2/3 of the full length right here equals x plus 6. So instead of dealing with fractions, I went ahead and multiplied both sides by 3 to cancel out the fractions. That's why you have this here. So then that cancels. So now I have 2 times the quantity 3x plus 8 equals 3x plus 18. Distributive property now. 6x minus 16 equals 3x plus 18. Subtract the 3x across, add the 16 across, 3x equals 34, and x equals 34/3. You can leave it like that. You don't have to change it to a decimal. Lastly, we have if dg equals 7, dg is 7 right there. Remember, that's going to be half of the longer piece. That makes this 14. What is bg? It's a question right there, 14. All right, that goes ahead and explains all the problems. 22 minutes.